All right, folks, these two topics here, relations and functions, will be my last topics in the set theory series. First of all, thanks for coming. Make sure you subscribe to my channel, like and share this video, leave comments or questions under this video. Now, you see the picture you're looking at there. That's how I represent the relationship between functions and relations. You see, the functions are inside the relations, right? That means every function is a relation, right? But not every relation is a function, because both functions and relations are related to the topic we discussed before, the topic called the Cartesian product. Cartesian product of two sets, right? So I'm going to expand on that a little bit to show you an easy way, to represent a Cartesian product. Because once you understand that, then the concepts of relations and functions will become a little bit easier for you. So let's do that first. All right. Okay, recall that we talked about the Cartesian product of two sets, right? If you have two sets, A and B, and then the cross product of those two sets consists of ordered pairs, right? Such that the first element there in the order pair belongs to A, the second element belongs to B. You see it there? So basically, this first element here, the first element of the order pair belongs to set A, the second element belongs to set B. That's what that is saying. So remember we talked about that. I'm going to give you an example. Let me give you an example and then we'll move on to relation. Let's say we'll have these, let's say A is equals to this thing here, consists of 5, 6, and 7, right? And B, set B consists of 8, 9, right? So the Cartesian product of those two sets is what? It's A times B is equals to, remember? So you start with the elements of A, you pair it with the elements of B, right? So you say 5 paired with 8, 5 paired with 9. Remember that, right? And then you keep going. 6 paired with 8, and then 6 paired with 9, you see? And you keep going. 7 paired with 8, and 7 paired with 9. You see that? And then you close the bracket. So you record this. That's what we did this in the past. I just want to show you another way you can do the same thing, right? You got those two sets. You can do it this way. You can use what they call tree diagram. You can construct a tree diagram like this using those two sets. You start with the elements of A, like we did above. You draw 3 branches because A has 3 elements. So you put the elements like that, 5, 6, 7, right? And then now notice that B has 2 elements. So you pair with each element of A like this. You draw another 2 branch because B has 2 elements. So you pair like that, right? And then you use 5 to pair with 8 and then pair with 9. That's all. You save 5, 8, 5, 9. You see? We're coming up with the same thing we did above. And then you say 6, 8, and then 6, 9, right? And then you say 7, 8, 7, 9. See? Those are the same elements were found there. But I'm just showing you another way to do it. Another way to find the cross product, right? So once you pair it up, then you can bring down the elements in like you did it here. You see what I'm saying? So then you say A times B is the same thing. You bring all this down right here, like we did above. You just copied them down. So if it helps you, good. If it's confusing, don't worry about it. Some people might find it easier to use. Let's see, 8. Okay. 6, 9. All right. And then 7, 8, and 7, 9. Okay. So if the tree diagram doesn't help you, don't worry about it. So now we're gonna go ahead and define what is called relation. Okay. Now that we have defined, we have refreshed our memory on what a cross product means. We'll now define relation, right? Let's say we have two sets, A and B. A relation from A to B is a subset of the cross product of A and B. That's all. In other words, a relation, I'm gonna write it down. A relation is a set of ordered pairs, right? A set of ordered pairs, because that's what cross product is. A set of ordered pairs where each first element, right? Where each first element of the ordered pair, right, comes. I'm sorry, I'm going too fast. Each first element of the ordered pair. Of course you have many of them, of the ordered pairs comes from set A, right? And each second element of the ordered pair comes from set B. That's all that is saying, right? In other words, if you have two sets, right, set A and B, and you form a cross product of it, that's how you find relation, right? Like that, such that each element of each A comes from A and each B comes from B. That's all. This is what is called a relation. Yeah, that's what is called a relation. It's not more than that. That's a relation right there for you. But there's some more terminology, right? This will help you when we go to talk about function. There's more terminology right here for you. The first, if you form a set of all the first element, right? Because now you have several ordered pairs. If you form a set of all the first element in the ordered pairs, right? That set is called the domain, right? The domain of the relation, right? And then if you form a set of all the second element, that set is called, I want to use the word the codomain. I mean, there's a word called range, but let's use codomain. In other words, you take all the first elements, right? You form a set, right? And then you get the domain right there. You form a set A1, A2, A3. you form a set. That's the domain. And you take all the second element, B1, B2, B3. That's the codomain, okay? Now, why is good to start with relation? Because when you get a function, you see, a function is just a relation, but with a different little modification, okay? So let me give you an example. All right. Let's say you're given two sets, right? A, you're looking at their B right there, and then you are required to form a relation from set A to set B. Now you can do it any way you want, but let me use the tree method to demonstrate how you form the relation. Okay, since the first set A has three elements, I will go like that. I will draw three branches like that. Put the elements. Okay, since a B also has three elements, then you form three branches. That's all. You form three branches like that. That's all that, how you use that. And then from there, you start distributing the elements, forming an ordered pair. Other pairs from, from the elements, right? Now you go 1 and 4, right? 1 and 6, and then 1 and 10, right? And then you continue, you move to 2, 2 and 4, 2 and 6, and then 2 and 10, right? So you continue, you move to 3, 3 and 4, 3 and 6 and 3 and 10, right? Basically that's it. So this is how you do. You can do it the other way, it doesn't matter. So then you say the relation between from A to B is basically this. This ordered pair here, and then this ordered pair. You just list all of them. That's all. Okay, that's all. You list all of them. So that's the relation right there. The relation from A to B. You just list them like that. Like I said, it's you can write it. You can write it as equals to A times B. That's okay, because a relation is a subset of cross product. Okay, so let me give you another example that may make sense a little bit. All right, note that the domain, the example I just gave you, note that the domain of that relation is consists of that set that contains elements 1, 2, 3. Because you see, when you list the first elements of that relation, right, you're forming a set, and then when you form a set, there's no repetition. So you can't say 1, 1, 1, 1. No, you just say 1, and then 2. You can't say 2, 2, 2. So, and same thing with codomain. Codomain is a set. So that's the codomain right there. Now, there are different types of relations, but I'm just gonna cover one of them, and it's called inverse relation. Yeah, it's called inverse relation. Okay. Um, I mean the other relations. There's no need for me to cover them. I just want to introduce you to relation. Then from there, I'll go to functions. Functions are the most important thing. But when we get to function, you hear about inverse functions. So that's why I want to talk about inverse relation, right? Now, if you have a relation, I'm going to use the word R. You have a relation that is defined as ordered pair A, B, such that A is an element of set A and B is an element of set B, right? Then the inverse relation is written like this. It's written like that. And it's defined as, you just switch the elements, right? It's defined as B A instead of AB. The same thing such that A is equals to A and B is equals to B. That's all. You just switch it around, That's all that means, man. Now we'll move on to function. What is a function? A function is a relation, right? Let's say you have two sets. They're given two sets A and B. A function, right, from A to B is a relation from A to B, right? A function from A to B is a relation from A to B, but it's a relation such that each element of A, right, appears exactly once. Appears exactly once as the first element, okay? The first element of the ordered pairs, right? Of the ordered pairs. Basically, that's all. So that's the condition you get when you define a function. Okay, so we'll have the same definition we had before under relation. A function has a domain. This is very important. Domain and codomain. Codomain. Usually they call the codomain, they call it a range. You will hear that a lot in mathematics, okay? Again, the domain is a set consisting of all those first elements in the function, right? And then the codomain is a set consisting of all the second elements in the definition of the function. That's all, right? That's all. This consists of set of all the first elements, right? All the first elements. Okay, right? And the range consists of set of the second element, okay? All the second elements, okay? That's all. So I don't want to go deep into this to confuse some of you. Just understand the basic definition. We're going to cover this later on when I get to algebra. But I want to introduce you to the idea, the concept here. That way you understand what a function is. A function is just a set, right? It's a set that comes from a relation, right? But it's a special set of type of relation. All right, let's look at some example. Consider this. Let me see. Consider this. Let's just try it. 3, 6, 4, 6, 7, 1, 8, 9. Yeah, look at that. Is that a function? The answer is yes. Why? Because all the first elements are distinct, right? None of them is repeated, so that's a function. Now look at this example. Let's see. 4, 3, 6, 7, 8, 9, 6, 10. Okay. Is this a function? Is this a function, right? We can ask this question. Is this a function? That's what we're looking for. This one is yes. This one is no. Why? This is not a function. Why? Because look at the first element. 6 is repeated. You see that? This one and this one. The first element is repeated. See? So that's not a function. So let's look at another example. Look at this. Let's see. It's 1, 3. All right. 3, 2, 4, 1, 2, 1. Okay. Is that a function? Yes. Because you see, look at the first element, none of them is repeated, right? So this is a function. So yeah, this is a function. All right, let's leave this here. I just wanted to introduce you to functions, right? And I couldn't talk about functions without talking about sets, right? From sets, you get a Cartesian product of two sets, which consists of ordered pairs, right? And function is no more than ordered pairs, but with the first element not repeated, okay? So the thing is, I'm going to talk more about functions when we get to college algebra and pre-calculus. So I think this is enough for you to understand that, when we talk about function in the future, it has to do with two sets. Okay, next I will start with college algebra, probably also start with pre-calculus. Maybe I do them both at the same time. Maybe I start with one, so, all right, please subscribe to my channel, like and share this video. If you have any questions, leave it down under the video. I will get to them as soon as I can. Next time we'll start with college algebra and possibly with pre-calculus, okay? All right, thanks for coming. I'll see you in the next video.